Alright, welcome back. Our final topic for our limits exploration, the intermediate value theorem. So, what the intermediate value theorem says, if f(x) is a continuous function on a closed interval, a to b, you select this interval, and the outputs at the endpoints are not equal, then for every value m between your endpoint outputs, there exists at least one value c, right? So an input such that f of c, right? So that input, or the output to that particular input, exists. Okay. Now, in essence, what does this 3.5 lines of text say? It says a continuous function cannot skip x. And the way I like to explain this is if you've ever gone on a plane or you've ever watched a plane, okay, in order for the plane to get to an altitude of 20,000 feet, right, it starts on the ground, and it doesn't like, I think his name was like Night Watcher or something like that from X-Men, right? The plane doesn't just, boop, 20,000 feet now, you can take off your seatbelts, right? It goes from 0, and it starts to increase, 1 feet, 2 feet, 3 feet, 4 feet. We're obviously accounting for all the measures in between continuously until it finally reaches 20,000 feet. So that is the real world connection to the intermediate value theorem. And the intermediate value theorem just helps us prove that a function is continuous. In addition to one other thing that we'll get to after this quick commercial break. Okay. Let's say that we need to prove that sine of x equals 0.3 has at least one solution. Okay. So I know the intermediate value theorem, but you're definitely going to want to use it maybe as like a little bit of a checklist. So first thing, right, we need to say that the function is continuous. So we know that, right? Since sine of x is continuous, we can apply the IDT. Right, if the function is not continuous, we're done. Now, like I said before, let zero to pi over 2 be our interval. You might be sitting there like, why those two values? Why not -4 to 4? If you can calculate sine of -4, please do so. But that just comes with some experience and some comfortability when it comes to working with these functions. You are in control. If you wanted to, let's say we didn't have a trigonometric function, we just had a polynomial function, which we will, or you will get to. If you want to pick a giant interval, -1,000 to 1,000, go ahead. But you need to also definitively make sure that, you know, your input and output are going to work the way that you need them to. So let's allow this to be our interval, okay? Because we need this interval to trap this value. So you can say thus, or then, sine of 0 is equal to 0, and sine of pi over 2 is equal to 1. Now the next part, the intermediate value theorem says, since f of 0 is not equal to f of pi over 2, right? Because the outputs of the ends of our bounds cannot be equal. And 0.3 falls between 0 and 1. The equation sine of x equals 0.3 has at least one solution in 0 to pi over 2, right? Because it's just like the airplane, right? If we know that between these two inputs, right, so 0, pi over 2, right, we have 0, 1, like a plane, right, it might, whatever, right, it might have this crazy convoluted path, but at some point, because like a plane, it's going to pass 0.3. And that's all we need to show. Now, the corollary, or addendum, to the intermediate value theorem says that if f of x is continuous on a, b, so that's not changing, and if f of a and f of b are non-zero, that's key. Hold on to your seats. And have opposite signs. Right? So they're not non-zero. So they're not non-zero. So they're not. Sorry, they're not zero. And have opposite signs. So one's gonna be positive, one's gonna be negative. Right? So positive, negative, or vice versa. Then we can include f of x as a 0 root x-intercept solution in a b. So this, I think, is more important than the intermediate value theorem itself, but it's a subsidiary of the intermediate value theorem. So property of transitivity, I digress. Okay. This allows us to prove the existence of roots, which is critical when trying to understand function behavior and the other aspects that are associated with functions. So, if there are any questions, reach out to me or leave a comment, I guess, 8 videos later or 12 videos later, however far I am. And pick it back up in chapter 3 in most textbooks, where we begin differentiation. See you there.